It has got a special name. When you write this and you don't write the first medium, it is this. What is it called? Absolute refractive index. What is it called? Absolute refractive index. ठीक है, चलो उसके बाद what else? Did I give you this formula? A2 upon V1. ये वाला नहीं किया ना, तो ये आज कर. I think यहाँ तक किया था. So everybody is familiar till here. Till absolute refractive index, everybody is familiar. When do we call refractive index as absolute refractive index? When the first medium is air. तभी तो V1 equal to C हो जाएगा. ठीक है ना? What is C? You have present last lecture, so you have to like see the video lectures. उसके बाद you have to ask doubts separately. जिसने मिस किया सारे video lectures देखो. ठीक है? और ये क्या है? V is the speed in the second medium. ठीक है? तो जब भी पहला मीडियम एयर होता है तो हम ये वाला मीडियम जो है एयर को स्पेसिफाई नहीं करते. उस टाइम पे जो रिफ्रैक्टिव इंडेक्स है उसको क्या बोलते हैं? एब्सोल्यूट रिफ्रैक्टिव इंडेक्स. कौन से मीडियम का? कौन से मीडियम का? सेकंड मीडियम. जो मीडियम लिखा है उसका. समझ आया? ठीक है. और कभी-कभी हम सेकंड मीडियम भी नहीं लिखते. तो समझ जाओ ये जो रिफ्रैक्टिव इंडेक्स है किसका है? ये वाले मीडियम का है जिसमें स्पीड क्या है? v. समझ गए? सिर्फ रिफ्रैक्टिव इंडेक्स लिख के छोड़ देंगे c by v. मतलब वो किसका रिफ्रैक्टिव इंडेक्स? सेकंड मीडियम का. समझ गए ना? अब तो जब मीडियम गिवन रहता है, अभी समझो अभी हमारा ये क्या हो गया? How will you read this?
Index of glass.
Very good. Refractive index of glass with respect to water. ठीक है? तो ये जब मीडियम का नाम का अल्फाबेट से भी हम लिख सकते हैं. ठीक है? So refractive index of glass with respect to water ऐसे लिख सकते हैं. तो इसको हम ऐसे कैसे लिख सकते हैं? देखो क्या आएगा? V1 VW divided by VG. ऐसे लिख सकते हैं? लिख सकते हैं ना? V1 V2 ये वाला फॉर्मूला से लिख सकते हैं ना? तो ये क्या? V1 इंसिडेंट मीडियम का वेलोसिटी और Vg क्या हो गया? रिफ्रैक्टिंग मीडियम का वेलोसिटी. ठीक है? तो अगर हम इसको नंबर के फॉर्म में लिखें तो हम इसको ऐसे भी लिख सकते हैं. ऐसे. यही चीज है, दोनों सेम चीज है. You get used to it now. ठीक है? अब हम इसमें क्या करने वाले हैं? ये वाला जो मीडियम है इसमें दो अलग-अलग मीडियम है ना, क्लियरली ग्लास और वाटर. तो इसको हम क्या बोलते हैं? रिलेटिव रिफ्रैक्टिव इंडेक्स. क्या बोलते हैं? रिलेटिव रिफ्रैक्टिव इंडेक्स. रिलेटिव रिफ्रैक्टिव इंडेक्स. ठीक है? ये क्यों हमने अब टर्म ले लिया रिलेटिव? उसको डिस्क्रिमिनेट करने के लिए एब्सोल्यूट रिफ्रैक्टिव इंडेक्स. समझ में आया? जब दोनों मीडियम स्पेसिफाई करते हैं तो क्या हो गया? रिलेटिव रिफ्रैक्टिव इंडेक्स. और जब एक ही मीडियम स्पेसिफाई करते हैं तो फर्स्ट मीडियम अंडरस्टूड है कि एयर है, तो तब उसको क्या बोलेंगे? एब्सोल्यूट रिफ्रैक्टिव इंडेक्स. क्लियर हो गया नोमेनक्लेचर? अच्छा. नाउ वी विल डिराइव अ रिलेशन बिटवीन रिलेटिव रिफ्रैक्टिव इंडेक्स एंड एब्सोल्यूट रिफ्रैक्टिव इंडेक्स. तो इसमें हम क्या करेंगे? वी कैन मल्टीप्लाई डिवाइड बाय c. ठीक है? ये कर सकते हैं मल्टीप्लाई डिवाइड बाय c, क्योंकि एब्सोल्यूट रिफ्रैक्टिव इंडेक्स में हमको c चाहिए है ना. तो अब देखो, so therefore we can write it as yes, so mu21 is equal to c by v2 into 1 upon c by v1. ये कर सकते हैं. v1 को हम न्यूमरेटर और डिनोमिनेटर में डिवाइड कर सकते हैं. ठीक है ना? so we'll get this correct. तो अब ये क्या हो गया? c by v2 is mu2 और ये क्या है? अपॉन ये हो गया mu1. ठीक है? दोनों का रिफ्रैक्टिव एब्सोल्यूट रिफ्रैक्टिव इंडेक्स का रिलेशन ये बनेगा. ये So you can express relative refractive index of two mediums in terms of their absolute refractive index with the help of this formula. ठीक है? अच्छा, अब इसमें एक लास्ट फॉर्मूला और बचा है. लास्ट फॉर्मूला क्या है? उसको नंबर दे दे जाओ. ये हो गया 1 2 3 3. उसके बाद ये हो गया 4. अब फिफ्थ हम देख लेते हैं. सिंस अगर ये जो डायग्राम है हमारा n21 इज इक्वल टू sin i बाय sin r, ये हमको पता है. इसको हम 1 अपॉन sin r अपॉन sin i लिख सकते हैं. लिख सकते हैं कि नहीं? ठीक है. तो अब देखो यहाँ पे ये हो गया हमारा i, ये हो गया हमारा r. ठीक है. तो जब लाइट ये डायरेक्शन में ट्रेवल कर रही थी, ए ओ के डायरेक्शन में, ठीक है, तब ये पॉइंट पे ओ पॉइंट पे स्नेल्स लॉ लगाओगे. स्नेल्स लॉ कहाँ पे लगेगा? एट द पॉइंट ऑफ इंसिडेंस. तो क्या मिलेगा हमको? ये मिल जाएगा. ठीक है ना? व्हेन द रे इज ट्रैवलिंग लाइक दिस, तभी तो लाइट कहाँ बेंड हो रही है? सेकंड मीडियम में. और कहाँ से आ रही है? फर्स्ट मीडियम से. करेक्ट. तो स्नेल्स लॉ अप्लाइड एट पॉइंट ओ क्या मिलेगा? sin i बाय sin r मिलेगा. ठीक है ना? लेकिन अब यहां से जब जाएंगे, यहां से समझो हमारा b जो है, अब सेकंड मीडियम से लाइट जा रही है फर्स्ट मीडियम में. ठीक है. तो स्नेल्स लॉ क्या होगा? उस टाइम पे एंगल ऑफ इंसिडेंस क्या होगा? r. जब b से o की तरफ जा रही है तो एंगल ऑफ इंसिडेंस क्या हो जाएगा? r. और यहां से यहां जा रही है तो एंगल ऑफ रिफ्रैक्शन क्या हो जाएगा? i. तो sin r बाय sin i को तुम ऐसे लिख सकते हो. रिफ्रैक्टिव इंडेक्स ऑफ सेकंड मीडियम हमारा अभी फर्स्ट मीडियम है और फर्स्ट मीडियम हमारा सेकंड मीडियम, ऐसे लिख सकते हो, है ना? तो sin r बाय sin i क्या है? n12 है. करेक्ट. ये रिलेशन. तो देयरफॉर हमको क्या मिल गया? n21 इज रेसिप्रोकल ऑफ n12. ये मिल गया. दिस इज बाय मेयर एप्लीकेशन ऑफ स्नेल्स लॉ. सेम सिचुएशन में अगर ये ही पाथ ऑफ लाइट से हम पीछे जाते तो हमको ये मिल जाता, क्योंकि पेयर ऑफ मीडियम सेम है. तो जितने एंगल से इधर बेंड हुआ है वही एंगल से उतना डाइवर्ज होगा. ठीक है ना? फॉर द सेम केस इफ यू अप्लाई द स्नेल्स लॉ इन द ऑपोजिट डायरेक्शन, you will get sin r by sin I as n12. Clear? Clear by definition of refractive index. So we have these 5 relations and the numericals will be asked on these relations. Okay? So you have to identify the situation and apply one of the formulas. So now we'll discuss what is called as refraction through a rectangular glass slab. So before that, if anyone has any question, you can ask. Right? Question 4 is relation between relative refractive index and absolute refractive index. ठीक है. ये सब अलग अलग रिलेशन. ये एक एग्जांपल दिया है. एग्जांपल ठीक है, ये तुम्हारा क्या है? Absolute refractive index. सबको मैसेज मिल गया था? लेक्चर चेंज। ठीक है, तो अगर इसमें कोई डाउट नहीं है तो विल नाउ स्टार्ट विद refractive index applied to a rectangular glass slab. आ जाओ। But sit on one side, huh? Done writing, everyone? So those here NCERT book, right? So what we are going to learn now is actually activity. Okay, activity means it is you have to learning by doing. So in your lab, probably you will be provided with a rectangular glass slab, and you will be asked to do this experiment. Huh? Are the labs open now?
Yes, sir.
So this experiment have you done?
No, sir.
In 9th, 10th, anywhere? Okay. Huh? Doing tomorrow, it is expected. Okay. So we'll try to understand. So you'll be, your theory will be clear. So tomorrow you can actually practice it also, or whenever the experiment happens. So what you have to do is, imagine this is your rectangular glass slab. Okay. So it is a rectangular glass slab. So obviously it is a transparent medium, right? It's thick. It's thick and wide, and also has a height, right? So it is thick, wide, and has a length. So what you do is, on the experiment table, first you place a chart paper. Okay, place a chart paper, place it in the middle of that, and then run the pencil to the base of the slab. Okay, so once you run the pencil on your paper, you will get this kind of rectangle. So this is the base of the slab, and then you can name it A, B, C, D. So let's do step by step. You have a rectangular glass slab placed on the table on a chart paper. You have made the boundary, or you run the pencil through the base of the slab, and you get this kind of impression. Now what you are doing is, so these are the two sides, right? So I am keeping it on the chart like this, but on the board I am drawing like this. So okay, so this is one side and this is the other side. So one side is facing the experimenter and the other side. Okay. So what we are doing is, we are taking two pins, right? And we'll insert it on the chart paper. Okay. So we'll insert two pins. and then we will view those pins from the other side. Okay, let's say I have one pin here, one pin here, and now I am looking at those pins from the other side. How I have to view so that only one pin is visible, right? So what does it mean? If only one pin is visible, let us say right now both the pins are visible to me, right? Now I adjust my eyes in such a way that now only first pin is visible, the behind one is not, and you have to close one eye, right? So when only one pin is visible, that means both the pins are in the same line, right? Both the pins are in the same line. So let us say I inserted one pin here and the other pin over here. These are the two pins, right? And I saw it from the other side. And then while seeing from the other side, I inserted one more pin. Okay? So what did I do? I inserted one more pin. Right? And now this inserted pin, when I'm seeing, it should block the other two. Okay? So only one last pin should be visible. Now, while looking at this pin, I insert one more pin now. And what? And only the last pin should be visible to me again. So what does it tell me? It tells me that all the pins are in the same line. Correct? Okay. Now, and this is experiment. This is experiment. So while seeing, I am seeing all the four pins in the same line. Okay. Hang on. Now you remove all the pins. So you have the pin impressions. Okay. Now join those pin impressions with a straight line on this border. Okay. Same thing you do here. Now when I complete the ray diagram, I see that while seeing I was looking all of them in the same line, right? But when I look it on the paper, it is different. So I have these 2 points within the glass. Now when I join it, this is what I get, which is fair. Because here you have air medium, this is glass, right? And again I'm coming into air. So obviously, at this point there will be a refraction. It will suffer refraction again. So, and what is the original direction? This is the original direction. So what do I get? Is there any deviation in the emergent ray? Is there any deviation? Huh? What is the meaning of deviation? So, change in the path when the direction is different. Is the direction different? Direction is not different. So, the output ray is not deviated. But what is the difference over here? It has got lateral shift. It has shifted from here to here. From X, it has come to Y. Y ले लो या X dash ले लो. चलो. You be happy. Okay. So the original light ray path was this. After refraction by a rectangular glass length, it has laterally shifted. Now there is no bending. There is no deviation. Huh? Why there is no deviation? There is deviation inside the medium, but outside, since the pair of medium is same. Okay, we just saw here. We just saw here. Now here, whatever is the Snell's law, the same Snell's law is now diverting the ray away from the normal, whatever it had bent or gone close to the normal. Understood? So plus minus effect. So there is no deviation in case of refraction of light by rectangular glass slab, just lateral shift. Okay, this is the finding of the experiment. So when you do the experiment, you see all of them in the same ray, but it's actually not in the same path. There is refraction taking place within the medium. Okay. So what is the conclusion of the experiment? Rectangular glass slab only laterally shifts. Emergent ray. That is no deviation. Without any deviation. Without any deviation means bending. That is bending. No bending. Okay. Without any deviation with respect to. So with respect to, I write in short as WRT. The incident rate. So this is the conclusion. So this is your I1. This is R1. This is I2. And this is your R2. Also, since so these are the findings. Okay, that is incident angle is equal to emergent angle. I1 has to be equal to R. So when you apply this Snell's law, you can find it out for yourself. Okay, what is Snell's law? Snell's law at O. At O. What is it? Refractive index of glass with respect to air. What is it? Sine of I1 upon sine of R1 at Q. What is the refractive index of glass with respect to air? Should I write 1, 2? We have written the medium as 1, 2. This is not 3. This medium is also 1. Okay. So write it like this: N2, 1. So at Q, what is N2, 1? Sine R2 divided by sine I2. Correct? When you say 2, this is 2. So 2, 1 means you have to take the direction like this. So both are N2, 1. This means sine of I1 upon sine of R1 is equal to sine of R2 upon sine of I2. This is not in the book, I am just giving you from my side, okay? But R1 is equal to I2. R1 is equal to I2, it should be not I1. Alternate angle, you should have pointed this out. R1 is equal to I2. Okay, what is this? R1. Refractive angle of refraction at this point, at O. And this is angle of incidence at point Q. Okay. So just make this correction. R1 should be equal to, angle R1 should be equal to angle I2. So this will cancel. Why? Since R1 is equal to I2. They are alternate angles. Why alternate angle? Because normals are normal to the parallel side will also be parallel to each other. And then this is the transversal. OQ is the transversal. So this angle will be alternate angle. So if sine I1 is equal to sine R2, right? So when is it possible? This means I1 is equal to R. Okay. When will sines of I1 R2 equal? Only when the angles are same. Okay. So this is obvious. So this proof I have given you optional, right? Proof of I1 equal to angle R2 is optional. Okay. Generally, they will ask you to draw the diagram and write what is the experimental finding. That's it. Okay. This mathematical proof is only for your understanding. It is not required. WRT is with respect to, yes. So Okay, so with this